Go.
Hi, I'm Evan Skillman. I'm a professor of astronomy at the University of Minnesota. For my research is based mainly on nearby galaxies and especially little dwarf galaxies. And one of the best parts about being a professor at the University of Minnesota is I get to share my enthusiasm for my research with the hundreds of students that I teach every year, particularly freshmen, people that are just new to the university. They come and they take a course from me in astronomy, and they learn as much as they've ever wanted to know about astronomy. You know, we've just discovered one of the lowest metallicity galaxies ever known. We used the Large Binocular Telescope, which the University of Minnesota has a share of, to obtain a spectrum of that. And the spectrum tells us the different chemical abundances. The most important one for this purpose is oxygen. So we measured the amount of oxygen relative to hydrogen in this galaxy, and it shows up, it's tied with some of the lowest known, which, for reference, it's about 50 times lower in metallicity in oxygen abundances than the Sun. And this is very exciting. I'm about to travel down to Arizona to use some optical telescopes down there. We're searching for the effects of small galaxies colliding into each other. We found these galaxies that have unusually high star formation rates. They're called starburst galaxies. And the hypothesis is that the reason that the galaxies are forming all these stars right now is that there's a collision that's been induced. The star formation has been induced through the collision, and that's why these little dwarf galaxies appear so bright right now, because of all this star formation. If this hypothesis is true, we should be able to see some little tail of stars streaming out from the galaxy that showed the history of this interaction. And we're using the telescopes to look for that. I'm a member of the team called the Panchromatic Hubble Andromeda Treasury Program. And Andromeda is the largest, it's the nearest spiral galaxy. It takes up a large angle on the sky. And we were awarded orbits with the Hubble Space Telescope, observing time on the Hubble Space Telescope over the course of 3 years. It's one of the 3 most ambitious projects ever conducted with the Hubble Space Telescope. And we break up the Andromeda galaxy into these tiny little fields of view that Hubble can see, and we mosaic one quadrant of Andromeda at this incredibly high resolution. And through this, we can now photometer millions and millions of stars and understand for the first time the distribution of the masses of all the stars in a large galaxy. We've been part of this large Hubble Space Telescope survey of the Andromeda galaxy, and in this large program we identified all sorts of stellar clusters. But there were too many of them to identify. There's thousands of images, and there were too many for the professional astronomers to go through and find everyone, and it's too difficult a problem for most computer software to handle. And so we used citizen scientists we put all these images out on the web in an organized way. People all around the world went through and analyzed thousands of images. Every image was seen by a minimum of 50 different people. They searched for stellar clusters, and they've identified a catalog of over 2,000 stellar clusters in Andromeda galaxy. It all took place in about 12 days, and it would have taken the professional astronomers about a year to get all of this done. It's been a fantastic project.